All right, number 1. Explain how to add complex numbers. So all you have to do is just add the real parts and the imaginary parts. All right, so if I have two complex numbers, a plus bi, and I want to add another complex number to that, let's say it's c plus di. The a and the c are the real parts, and the b and the d are the imaginary parts. And of course these represent just ordinary numbers, real numbers. Okay, so the a, b, c, and d, that is, are just real numbers. So you just add the real parts, a plus c, and then the imaginary parts rather, the b plus d, and put that in parentheses, write an I after the b plus d. So whatever this result is will be next to the I, and there's your new imaginary part. So there's your new real part, your new imaginary part. Number 3. Give an example to show the product of two imaginary numbers is not always imaginary. Alright, now here your answers will vary, depend on the examples you come up with. So here's my example. How about 2i times 3i? So 2 times 3 is 6, and I times I is I squared. I squared, of course, is negative 1, so that's 6 times negative 1. And that's, of course, negative 6. So this is no longer an imaginary number, it's a real number. Alright. Number 5. For the following exercises, evaluate the algebraic expressions. So we have f of x is x squared plus x minus 4. What we want is f of 2i. Evaluate f of 2i. Evaluate, of course, in this context means compute it or calculate it. Plug in 2i for x and then compute the result. That's what they mean by evaluate f of 2i. So all you have to remember when you do this is I squared equals negative 1. Everything else works as usual. Alright, so plug in 2i there, you get 2i squared plus 2i minus 4. Alright. So when you're squaring a product, remember the rule. A times b in parentheses squared equals a squared times b squared. Similar rule applies to quotients. Alright, if you're dividing a by b, a divided by b in parentheses squared would be a squared over b squared. Alright, so this is 2 squared times I squared plus 2i minus 4. And I squared, of course, is negative 1. 2 squared is 4, so that becomes negative 4 plus 2i minus 4. Negative 4 plus negative 4 is negative 8, so you get negative 8 plus 2i, and that's written in standard form for a complex number. Alright, which is what you want to end up with when they say simplify it. So you want to write it as just a regular or complex number in standard form, a plus bi. All right. Number 7, if f of x equals x squared plus 3x plus 5. They want us to evaluate f of 2 plus I. Alright, so plug in 2 plus I everywhere you see an x. Be sure to use parentheses. Like that. Alright. Now use the rule here, the shortcut rule. A plus b quantity squared equals a squared plus 2ab plus b squared. You must have seen that before from your Algebra 1, Algebra 2 days. Alright? They should have gone over that rule pretty hard. And now you can use it with this. So this is 2 squared plus 2. So a is 2, b is I here. So 2ab, so that's 2 times I plus b squared, that's I squared. And on this one, you just distribute the 3 through there. So that's plus 3 times 2, which is 6, plus 3 times I is 3i, plus 5. Alright? So this is equal to 4 plus 4i plus I squared is negative 1, so that's minus 1, plus 6 plus 3i plus 5. Now just add all the real numbers. 4 minus 1 is 3. 3 plus 6 is 9. 9 plus 5 is 14. And now add the imaginary numbers. All right, you got 4i plus 3i is 7i. Plus, that's positive, 7i. So we have 14 plus 7i. All right, everything's taken care of, I believe. All right, so there we go. Number 9, if f of x equals x plus 1 over 2 minus x. So they want us to evaluate f of 5i. Okay, so plug in 5i everywhere you see the x, so you got 5i plus 1 over 2 minus 5i. Okay, now we're not quite done. This is not in simplified form because we have a division here of complex numbers. So what we want to do is actually perform that division and then proceed from there. So if you remember how to do this, to divide complex numbers, you multiply top and bottom by the conjugate of the denominator. Now the conjugate of the denominator is formed when you take the sign opposite the one that's there for the imaginary part. Alright, so the sign, rather, by that I mean S-I-G-N, the sign, whether it's plus or minus. Alright, so this is minus next to the imaginary part, so the conjugate would be formed by writing a plus, 2 plus 5i. You leave the sign on the real part alone, okay, when you form the conjugate. And I'm going to also write the numerator here in standard form, 1 plus 5i, while I'm at it. 2 minus 5i, that's already in standard form. Multiply by the conjugate top and bottom. 2 plus 5i over 2 plus 5i. So what I'm doing is I'm multiplying by 1. This the numerator equals the denominator, so that equals 1. So I can still write the equal sign here. All right. I don't want to change the value of this expression, but I do want to manipulate it, change it a little bit so we can work with this. All right. So Now we have two binomials multiplying each other. All right. Now you could use the FOIL method, a plus b times c plus d. Right? And in the United States, they have what's called the FOIL shortcut method of multiplying two binomials. All right, so F stands, in FOIL, F stands for first, so you multiply the first terms, A times C, and then O stands for outer, A times D, so that's plus A times D. Inner stands for those two on the inside, B times C, and then L stands for last, B times D. Alright, so FOIL method's okay. I mean, you know I'm not really enthused about the FOIL method. I mean, it's a shortcut, sure, and a lot of people remember that, but it doesn't work for bigger polynomials. For example, if you have a plus b plus c times d plus e plus f, you can't apply FOIL to that because we have more than two terms in each one. All right. So how do you do that? Well, there's a general way to do these. You just take the first term, multiply it by each one of these. All right. And then you move to the second term, multiply it by each one of these, and then finally the third term, multiply it by each one of these. And if there's a fourth term, you would do the same thing over again. All right. So it doesn't matter how many terms there are, you can use this rule. All right, A times D, first term times this, and then first term times the second one here, AE, and then first term times the last, AF. And then you go to the second term and multiply it by each one of these, BD, BE, and then BF. And then finally the last one, CD, CE, plus CF. And you're done. This also works with this one the same way. First term times each one of these, that would be A times C, right there, plus A times D, right there. And then you go to the second term, B times C, right there, B times D, right there. So it's the same thing, all right? So just multiply each term in the first one times each term in the second one, basically. That's all you have to do. Now, if you don't believe this is true, just use the distributive property and have at it, all right? If you've got a lot of extra time. Anyway, now that we've had our little diversion here, let's go back to this, all right? So 1 times 2 is 2. And then 1 times 5i is 5i. So that's 2 plus 5i. And then 5i times 2 is 10i. And then 5i times 5i is 25i squared. I would write a negative 25 there, but I'll start doing that later. I want to make sure everybody's on the same page with me here. Alright, so I'm writing things out in detail right now. So here we have a minus b times a plus b, right? What's that? A minus b times a plus b. Remember doing these? That equals a squared minus b squared. You probably did it the other way around. When you did factoring in Algebra 1 or 2, you went a squared minus b squared equals a plus b times a minus b. That's how it's usually taught. Of course, this is equivalent to that. So a squared, that equals a squared, that's 2 squared, minus 5i squared. 5i in parentheses. Alright, so 2, let's see, what do we got here? This becomes negative 1 times 25 is minus 25. So we have 2 minus 25 is minus 23. That's the real part. And then the 5i plus 10i is 15i. Alright. And 2 squared is 4. And then minus 5 squared is 25, I squared is negative 1, so that's minus 25. So this is equal to negative 23 plus 15i over 4 plus 25. Minus a minus is plus, so that's 4 plus 25 is 29. Alright. Now we're almost done simplifying. If you have a fraction, a plus b over c, for example, you can write it like this, a over c plus b over c. Basically, you usually start with these two and then you add the numerators, right? They both have the same denominator, common denominator c, so you would just add the numerators and you'd get that result. You can go the other way, the other direction as well. That would be equivalent. Alright, so since they're equal, you can go either direction. So that's what I'm doing here. I'm going to do here. I'm going to split it up like this. Okay, so that's negative 23 29ths. That's the real part. Plus 15 29ths I. Alright. Now you could write that as 15i over 29, but usually it's written like this. Alright, 15i over 29 can be written as 15 over 29 times I over 1. You see that? 15 times I is 15i, 29 times 1 is 29. And you just leave the 1 off and you end up with that. Okay? So I over 1 is I, of course. Alright? So that's the way it's generally written, like that. Okay? So that should do it for us. There we go. Number 11. For the following exercise, determine the number of real and non-real solutions for each quadratic function shown. Alright, so here's the quadratic function that has been graphed. And you'll notice it touches the x-axis at 2 points, 2 x-intercepts. Those are the solutions. There are 2 real solutions, those 2 points, the x-intercepts. And those are real numbers, and that's when x equals those 2 locations, those 2 points, then the function value equals 0. Alright, so those are solutions to the quadratic function, alright, or roots. They're called roots or zeros. So there are 2 real roots for this one. And the same could apply if you had a graph that looked like this, opening downward like that. You still have 2 real roots. I may as well show the other situations you could have. If you have the quadratic function touching the x-axis at one point at its vertex, right there, that would be 1 real root of multiplicity 2, they say. And you'll learn more about that later in this chapter. What does multiplicity mean? You'll see. Alright, and then that also applies, of course, to opening downward like that, touching at the vertex. And you could have something like this, where it doesn't touch the x-axis at all. So in that case, you've got non-real roots. All right, they're complex number roots. So you can't see those. All right, you can only see the real roots with these x-y axes, a Cartesian coordinate system. Number 13. For the following exercises, plot the complex numbers on the complex plane. So we have 1 minus 2i. So the complex axis system looks like this. That r stands for real number, or the real part, and the I is the vertical axis. That stands for the imaginary part. So 1 minus 2i, so just plot 1 minus 2, 1 negative 2. Let's say that's 1 there. And that's minus 2 there. So just like what you're doing is plotting the point 1, 2 as if it were the xy coordinate system. Alright? So you'd go right 1 and down 2. Right there. Except instead of a y-axis, you've got an I-axis. Alright? And by the way, speaking of this as a complex number, you can look at that as a complex number as long as you, oops, that should be negative 2 there, sorry, negative 2. As long as you know that this is the imaginary part, the second coordinate is the imaginary part. And my old HP28S calculator handles complex numbers like this. You enter it into the calculator like that. You don't touch the I at all, right? There's no I key, small I key. Number 15, we have 0 plus 1i. Or you could just write that as 0 plus I, or just I. They're equivalent. Alright, so it's like plotting 0, 1. Alright, so don't go anywhere right or left, go up 1 unit. And there you go, right there. There's your I, or 0 plus 1i. 0 plus 1i. Number 17. For the following exercises, perform the indicated operation and express the result as a simplified complex number. So, we have 3 plus 2i plus 5 minus 3i. Alright, so just add the real parts and the imaginary parts. So you've got a 3 plus 5. That's the real parts. And then plus imaginary parts rather, the 2 minus 3. And then I comes next. So there's your imaginary parts, there's your real parts. So you get 8. And 2 minus 3 is negative 1, so that's just 8 minus 1i, or just 8 minus I. 8 minus I. Number 19. So we have negative 5 plus 3i. And then minus, parentheses, 6 minus I. Alright, so That's negative 5 plus 3i. Distribute that negative sign through, minus 6, minus a minus is plus I. Alright, so add the real parts. Negative 5 minus 6 is negative 11. And then the imaginary parts, 3 plus 1 is plus 4i. So negative 11 plus 4i. Number 21. So we have negative 4 plus 4i minus a negative 6 plus 9i. So that's negative 4 plus 4i minus a minus is plus 6 rather, plus 6, and then minus a 9i. So negative 4 plus 6 is 2, and then 4i minus 9i is negative 5i. So you have 2 minus 5i. Number 23, we have 5 minus 2i times 3i. So you just distribute the 3i through. You could do it on the right, or if you want, because of commutativity, you can move it to the left and distribute, whatever. Alright, so you got 5 times 3i is 15i. And then negative 2i times 3i is negative 6i squared. And that's 15i minus 6 times negative 1. I squared is negative 1, so minus 6 times negative 1 is plus 6. Now it's not simplified because it's not in standard form. So you put the real part first when it's in standard form, and the imaginary part next. Right? So now it's in standard form, it's considered simplified. Will your professor take points off if that were on a test and you wrote it like this? I don't know. Depends on the professor, right? But technically they can, because that's not considered simplified. Okay, and that's what the directions told you to do. So yeah, I wouldn't take a chance on that. Number 25. We have negative 2 plus 4i times 8. So just distribute the 8 through. 8 times negative 2 is negative 16. And then 8 times 4i is 32i plus 32i. And that's in standard form. So there's our answer. Number 27. We've got negative 1 plus 2i times negative 2 plus 3i. So negative 1 times negative 2, positive 2. Negative 1 times 3i is negative 3i. 2i times negative 2 is negative 4i. 2i times 3i is 6i squared, which is negative 6. So 2 minus 6 is negative 4. Negative 3i minus 4i is negative 7i. So you have negative 4 minus 7i.